This is Euclid Book 4, Proposition number 15, Part 4. And now we're going to say, and we're going to go through this real quick. There is a circumference ED, and this circumference is equal to EF. This circumference is equal to FA. This circumference is equal to AB. This circumference is equal to BC. And this circumference is equal to CD. Okay, so far so good. Now, because FA is equal to ED, what we're going to do is we're going to add circumference ABCD, this whole circumference right here, both to ED and to FA. And when we do, we can then say the angle FED, well, here's FED, or otherwise known as DEF, it stands on circumference FABCD. FABCD. Okay? Then we can go on to say that AFE, well, here's AFE, this angle right here, stands on circumference EDCBA. Well, here's EDCB and A. And because of this, by Euclid Book 3, that's right, if we go back to Euclid Book 3, proposition number 27, we can go ahead and say the angle AFE, which is AFE, is equal in size to DEF. DEF. And we can go through the entire hexagon here and say that for every single component. We have proven that this hexagon is equilateral. Now we have proven that this hexagon is equiangular. So now we have formed an equiangular and equilateral hexagon from a circle. But this proof goes on here. We then can actually say that any side of this hexagon is equal to the radius of a circle, of this circle, okay? So we can say that the length of ED is exactly the same as the length of EG. Because remember, GE is one of the 6 radii of circle AFEDCB. Okay? So now we're going to say that line ED is equal in size to GE. We can then go on to say okay, if we were to draw a tangent line to this circle, we could then form an equiangular and equilateral hexagon. We could also go on to say we can circumscribe and inscribe a circle inside this hexagon. And if you want to do that on your own time, you go right ahead. I'm done with this proof. All right. Well, now that you've seen everything that we needed you to see, you can actually see, if you stare at this long enough, that this does indeed form a perfect cube. And so therefore, if you're trying to draw a perfect cube, I would draw yourself a hexagon, erase some of the lines, and you'll have a perfect cube. All right. I will tell you more in a future video, so stay tuned.